Hi, my name is Ashok. I'm from FinEx Training Institute. We are providing free classroom training in Mumbai for one entire month for CFA aspirants so that they themselves can decide if they wish to continue this certification. Please feel free to contact us for further details. Thank you. So this video is about normal distribution Z score and confidence interval. Okay. So say for example, see generally your data, okay, generally your data gets distributed like a normal distribution, okay, like in a bell-shaped curve. Generally your data gets distributed in a bell-shaped curve. This bell-shaped curve is called normal distribution. So normal distribution, it refers to the probability, cumulative probability of distribution of data. Okay, so in a normal distribution, data gets distributed in a symmetrical way, in a bell-shaped curve, in a symmetrical way. That means symmetrical means like our body parts is symmetrical. That means left hand side is equal to right hand side. Okay, when left hand side is equal to right hand side, we say it is symmetrical. So over here also the distribution of data is all this part is 50 percentage and all right hand side it is 50 percentage. Okay, and that's why it is what, symmetrical. Okay, symmetrical. So most of the data are in normal distribution. These are symmetrical. Examples, like, you take the example of the weight of a human being. So the center part is called as the mean. So let's say the weight of a human being is 70 kg. So generally, maximum weight will be falling here, something like, let's say 50 to 90 kg, 50 to 90 kg, and then further it can go extreme also, left hand side as well as right hand side extreme level. Okay, but generally maximum data falls over here, and then it takes the shape of your bell shaped curve. Okay, so it is called as normal distribution, as in distribution of data, which and normal distribution is the probability of distribution of data, right? So other examples, if you want, you can take the example like in your class. On an average, imagine people are scoring, let's say, 60 percentage marks, and let's say 60, and something like maximum people are scoring between 40 to 80. Some people might be scoring more than 80 also, some might be less than 80 as well. Okay, by the way, this difference, this is called deviations. Okay, deviations. So over here deviation is 20, 20 left hand side, right hand side. Similarly here also deviation is 70 and 90. So here also 20, 20 deviations. Okay, now so similarly other example, you can take the example of height of a human being. So generally they will be something like between 4.5 foot to something like maybe 6 foot, and then some people might be more than that, some people might be less than that. So generally this is how the data gets distributed. Stock market example, generally the returns from your stock, you will get something like 15 percentage with some deviations. Okay, let's say 25 and 5 percentage. So generally this is the range within which the deviation falls for maximum investments. But again, it can go extreme level also, more than 25. It can go less than 5 percentage also, as I have shown over here, this part. Okay, so this is the observation. Okay, this is the observation. This is how the data is lying. So it has been observed that in a normal distribution, okay, in a normal distribution, this data, if I take this mean as 0, okay, so when I say mean as 0, I'm converting normal distribution. I'm converting normal distribution to a standard normal distribution. What does that mean? Standard normal distribution. So if I have to represent this normal distribution in a standard form, I will keep this mean as 0, and this is one standard deviation. So I'll keep this as +1, +2, and then +3. Okay, it goes for till 3 standard deviation. We can graph it like this. Similarly, left hand side -1, -2, -3. Okay, now the probability between -1 to +1, or -1 to 0, it is 34%, and 0 to +1, it is 34%. So overall this comes to 68% probability. So these are all the observations. Okay, these are all the data. Then if I want to cover till 2 standard deviation, it comes to total overall. Then this part will cover up 13.5%, 13.5, between 13.5 to 14% you can take. And so overall, if I add up all this, it will come to 95%. Okay, probability. So 95%. And then if I go for all these three, this will, you can consider as approximately 100%. This way you can consider. Okay, so these are the probabilities. So here it is remaining 2.5 remaining. How? Because if you calculate, this part should come to 50. So it will come to 50 if you add up all this. Okay, that's how. So 50 minus 34 minus 13.5, you will get 2.5. Similarly here also, if you calculate, it will come to total 50%. So these are the observations that we should be knowing about. Okay, this is about the distribution of data for a normal distribution. Okay, now what is Z score? So when I say +2 standard deviation, +3 standard deviation, standard deviation basically means the deviation from the mean. From the mean, what is the deviation? Okay, from the mean, what is the deviation? Then Z score will tell us the number of standard deviations. Number of standard deviations. Say for example, here it is 2. The Z score is 2 over here. That means from the mean, it is 2 standard deviation away. So this is the Z score. From the mean, this is 3 standard deviation away. This is the Z score. From the mean, this is -1 standard deviation away. So left hand side -1. So this is the Z score. -1 is the Z score. Here -2 is the Z score. -3 is the Z score. Okay, the formula to calculate Z score is equal to x minus mu divided by standard deviation. Say for example, if I want to find out, let's say, let me make a new table. Now let's say on an average I am getting 15% return with 10 standard deviation. So I'll write 25% because deviation is 10, then 35%, and then 45%. Similarly, here also -10 if I do, it will be 5%, then -5%, then -15%. So if I standardize it, it will be 0, 1, 2, 3, and -1, -2, and -3. Okay, so now if I want to know what is the standard deviation of this 25, 25%. So all I have to do is 25 minus mu is mean is 15. So 15 divided by 10. So when I calculate, it will come to 25 minus, so Z score is 1. So this is 1, which is mentioned here. Similarly, for 35, it will be 35. So Z score will be 35 minus 15 divided by standard deviation is 10. So 25, sorry, this is 20. Yeah, 35 minus 15, 20 divided by 10 equal to 2. So the standard deviation is 2 here mentioned. Similarly, if I say, let's say minus 5, if I take minus 5, then Z score will be, if I see on the left hand side, for Z score, let's say minus 5. So minus 5 minus 15 divided by 10, that is equal to minus 20 divided by 10, that is equal to minus 2. So here it is minus 2. So given any number, I can get the Z score. Say for example, I want to find out some other number in between. Say for example, let's say I want to find out for 27. Okay, 27 will fall somewhere in between here, 27. So what is the Z score or number of standard deviation for 27? So Z score for 27 is equal to 27 minus 15 is the mean divided by 10. So that will give me 12 divided by 10. So Z score will be 1.2. Now once I get this Z score, what is the use? Z score will help me to get the probability of the distribution of this data. So once I get the Z score 1.2, I have to go to the table. So here is the table. 1.2, Z score is 1.2. So 1.2 will come over here, 1.2, 0 here. It is 88.49 percentage. It is 0.88.49, and that is 88.49 percentage. So which is like the probability, that means the cumulative probability of data, till here, all this till here 27, it is 80 88.49 percentage, 88.49 percentage, right? And suppose if it is, let's say, let me take some other odd number also. Let's say if it is, if I want to find out for 29.5. Okay, so 29.5 minus 15 divided by 10 will give me 1.45. So how do I get the probability for this Z score 1.45? Okay, so 1.45. Now you come to the table 1.4. Okay, left hand side you should see 1.4, and then here up in the column you see 0.05. So when you add 1.4, so 1.4 plus 0.05 will come to 1.45 only. So this 1.45, where is it is matching, it is 92.65 percentage. So this is 92.65 percentage. Okay, so 29.5 will fall somewhere here, and the cumulative probability is 92.65 percentage. 92.65 percentage. Now why this table has been framed like this, left hand side some information, right hand side like 1.4 is here, 0.05 is here. This is just to just to save space, nothing else. Because see here, any Z score if you want to calculate, you might want to calculate for this, for the probability value for the Z score 1.1 or 1.11, for the Z score 1.21 or 1.31. Okay, so if it goes like this, it will consume a lot of space, like 1.0, 1.11, 1.12, 1.13, 1.14, like this. Imagine it will go to 1.2, then again 1.21, then 1.3, then, so it takes a lot of space. So what they have done is they have put some number on the left hand side, some on the right hand side, and it has been clubbed together. So it is purely to save space, nothing else. Okay, so this is how you are supposed to use z score, and with the z score you are supposed to find out the probability. All right, the next one is confidence interval. Now confidence interval is equal to mean plus or minus z score into standard deviation. Okay, now z score, see, confidence interval, the meaning of confidence interval is we want to find out a range of values around expected mean. Okay, around expected mean, and that is the reason we are using mean in the formula with a specific uh, probability. Okay, with a specific probability. Generally we find out this confidence interval with 90% probability, or 95, or 99 percentage. So 90 percentage of the time, what will be the range value? So if that is the case, that time my z score will be 1.65. so this is standard. Okay, 1.65. so already this has been found out. So if I draw like a graph, so this is 0, 1, 2, 3, and here -1, -2, -3. So 90 percentage of the time, the 90 percentage of the time, the data will fall between 1.65. So 1.65 is here, plus or minus, so minus 1.65 to plus 1.65. This is 90 percentage of the time. Okay, similarly for 95 percentage of the time, z score will be 1.96, almost 2. So that means here 95 percentage of the time. Then for 99 percentage of the time, z score will be 2.58. So these are the z score. Okay, now with this information, so this is also something must you have to remember. Okay, now with this information and with this formula, if I quickly do one sum, say for example, let's say the mean return is, let's say, 10.5 percentage, and standard deviation is 18 percentage. So standard deviation is equal to 18 percentage. Okay, so in that case 10.5 plus 18, 28.5. So standard deviation I'm writing here 18 percentage. This will be 28.5, then plus 18 will be 46.5. Okay, plus 18 will be 64.5. Similarly, left hand side, 10.5 minus 18 comes to minus 7.5 percentage. So 7.5 minus 18 comes to, no, 7.5 Here it will be 25.5 percentage minus. Okay. And here 43.5 percentage, and the deviation is 18. So let me, yeah, this is deviation is 18 percentage. So I'm just cross checking once in my calc. So now if I say 95 percentage probability, what is the confidence interval? With 95 percentage probability, what is the confidence interval? Okay, this is the question. So confidence interval is equal to mean is 10.5 percentage plus or minus 10.5 percentage plus or minus z score is, for 95 percentage z score will be by default 1.96 into standard deviation is 18 percentage. So 10.5 percentage plus or minus 1.96 into 18 percentage comes to 35.28 percentage. Yeah. So when I calculate this, I get minus 24.78 percentage to 45.78 percentage. So if I show this in the graph again, okay, so here it was 10.5. So 1.96 will come somewhere here, 95 percentage. So the data, the range is minus 24 point, here it should be minus 24.78 percentage, here it should be 45.78 percentage. So I can say with 95 percentage probability that the returns will be between minus 24.78 percentage to 45.78 percentage. This is confidence interval. Thank you.